Hello everybody. Let's talk about what a negative exponent is. Okay, now I would not ever start a discussion by talking about what a negative exponent is. I would always indicate what an exponent is first, and I have done that in another video, but let's say, in case it's not fresh on your mind, an exponent will involve repeated multiplication. So if I had something like 2 to the third power, that means that you take the 2 and you multiply by itself 3 times. Okay, like that, and then you would get 8. So it's repeated multiplication. But how would that possibly apply to 2 to the negative third power? How could powers even be negative? You know, I can multiply 2 by itself 3 times. Like, I can do something 3 times, but how do you do something negative 3 times? Okay, now I say that just to tell you, on the surface doesn't make sense. There must be something else happening here. Negative exponents must mean something a little bit different than ordinary exponents. Okay, because so far, at least what I've talked about in these videos, it would only make sense for an exponent to be a positive number. Okay, because they involve repeated multiplication. Now, I want to tell you what a negative exponent is by way of reminding you about a rule that I showed you. Okay, so I had this rule that I mentioned in another video where I said if you divide like things, you subtract the exponents in the order that you see here. So if I have like x to the power a and I divide that by x to the power b, then I can have one base, one power, and I subtract the exponents in this order. I take this one up here and minus that one down there. Okay? So if you're in a situation that resembles this, that's what you do. So here's what that would mean. I've got x to the fourth power divided by x to the seventh. I'm dividing like bases. Then I subtract the exponents 4 minus 7, and I get x to the minus 3 power. Oh, so there's that negative exponent again. Okay? Now, I said I would use this to tell you what a negative exponent was. Is there anything about this that would help us figure out what this might mean? Okay? Well, let's think of it like this. Is there some other way to break this down? I mean, do you have to use this rule? And this rule might be the truth, it might be accurate, and it might be applicable, but is there any other way? Well, yeah, you could do like this. X to the fourth power means we multiply the x by itself 4 times. And then x to the seventh power means we multiply the x by itself 7 times. Okay? Alright. Does that expansion, that understanding of what we're dealing with here, allow us some other way to reduce this? Well, we're dividing, we're canceling here. Like, what's x divided by x? What's any number divided by itself? It's 1. That's what canceling is in this case. And here I've got x again divided by x. Well, that's also 1. And again, and again. And so what am I left with? I'm apparently left with a 1 on top, because that's what's left after you cancel everything, is a 1. And then 3 x's multiplied together on the bottom. Okay, so if you apply the rule, you get that this is x to the minus 3 power, but if you just separate it all out, cancel what you can, you get that it's 1 over x to the 3 power. Okay? So that tells us how to understand negative exponents. Okay? As a consequence of the applicability of this rule and the natural understanding of what exponents are, then we can say, here's our meaning. X to the minus 3 power means 1 over x to the third power. So that's the whole key right there to understanding negative exponents. I could say things like this. I could say, let's speak in generalities. Some number x to the power negative n, okay, where that power is a negative number, could be alternately understood as 1 over x to the power n. All right? I want you to think that whenever you see a negative exponent, you move it to the other side of the bar. Alternately, if I had 1 over x to some power n, and that power is negative, so let's say 1 over x to the power negative n, then that power can be corrected to be a positive number by moving it above the bar. Okay? Now, it might seem weird that I'm saying above or below the bar, but every number is really a fraction. So there is a bar there. X to the minus n power is x to the minus n power divided by 1. Okay? And x to the n power is x to the n power divided by 1. Any number that doesn't appear to be a fraction really is, if you consider that there's a 1 under it. So do you see how like that negative power makes this thing that has the power pass under the bar to the other side? And now it's 1 over x to the n power. Okay, yeah. And then this negative power, it's like passed again through the bar to the other side and is now on top. Indeed. Okay. So that's how negative exponents are understood. We'll just move, if anything has a negative exponent, we'll just move it from either under the bar to on top of it, or on top of it to under it. Okay? Now let's go ahead and work this problem then. What could you say 2 to the minus 3 power was? Well, okay, here's our understanding of negative exponents. It's all summarized right there in that bubble. So this is the same thing as 1 over 2 to the third power. And 2 to the third power can be directly calculated, right? 2 to the third power is 2 times 2 times 2. So it's 1 over 8. Okay? All right, 1 over 8. That's how we can calculate 2 to the minus 3 power. Now, all right, so that's what negative exponents are. I wanted to talk about it in a way that we could bring it full circle, but let's do this. Let's give another few examples and then go on to something different. So with this one, are we okay with that? Y to the minus 7 is, well, I mean, maybe that's not the same thing as the letter x. Maybe it's a different variable, but the same principle applies. It's going to be 1 over y to the 7th and 1 over r to the minus 5 power. Same idea. It might not be the letter x, but the same principle applies. That's going to be r to the 5th power. All right, so that's the basic idea about what to do with a negative exponent. What if you saw something like this, though? 2r to the minus 5th power. Okay, now you know that the negative power means that something needs to be moved, and it's going to end up either under or above. But what if there's other numbers in the mix? Like, what's the 2 have to do with this, and so on and so forth? Well, let's think of it this way. Does that exponent, is it attached to the 2? It's not attached to the 2. Okay. Now, to make it clear that it's not attached, let's do this. Let's compare this example with something like this. See how these look so much alike? They look a lot alike. I mean, the only difference between these is the parentheses, but the parentheses makes all the difference. Okay. Okay. So all right, I want to figure out the way that I'm supposed to break down each of these. So in this case, that exponent of negative 5 is not attached to the 2 and has nothing to do with it. This is 2 times r to the minus 5 power. Okay, so like whatever you think you're supposed to do with a negative exponent, however you think you're supposed to understand it, only applies to the r. It doesn't apply to the 2. So it's like you've got this 2 sitting there, and it's times r to the minus 5 power, and so I guess like that by itself means this. It's 2 times 1 over r to the 5 power. Okay, but then if you wanted to put that together, here we're multiplying fractions. Right, and I've got 2, but let's put that as 2 over 1 times 1 over r to the 5th power. Why would I put the 2 over a 1? Well, because when you multiply fractions, the technique is to multiply straight across. So I've got 2 times 1, which is 2, over 1 times r to the 5th power, which is r to the 5th power. Okay, so that's what we could say about reducing 2 times r to the minus 5 power. Now, here I've separated it out into 2 different things and put it back together. But, I mean, if you see enough of this, if you practice and you're used to seeing how things are done, then you get to where you know that, well, this gets moved under the 2. That's what happens, okay? Right? The 2 stays where it is. It doesn't have an exponent. There's no reason to move it. The r gets moved under the bar, but that essentially puts it under the 2, okay? All right, so how would this one be different? Well, in this case, it's the thing that has the negative exponent, and whatever thinking goes along with that applied to it is 2 times r. It's this whole quantity that's in the parentheses. So you could say like this. If you wanted to adjust or correct that negative exponent, you wanted to say something else about it, then this is what you could say. Okay? It goes under the 1, it goes under the bar, just like this. Okay? It's just like same thinking as in this first part of my rule. All right, now could you say anything else about it? Now, for me to have gone this far, I've corrected the negative exponent. I've written the negative exponent in a different way. Is there anything else you could say? Have we talked about any other rules or any other thought process that might be involved in taking this one additional step? Well, so exponents do apply across multiplication. All right? So we'll discuss that rule more in a little while. But yes, if I have 2 times r all to the 5th power, then each one of those factors gets the 5th power. This is 2 to the 5th power individually times r to the 5th power. So that's why it's 32r to the 5th power. Okay? All right, and then we can break it down all the way into that. Okay, so hopefully, with it being a short video, you see enough variety about how to look at negative exponents. There's always many, many more examples to do, but hopefully that's the idea. Let's try this one. Have we seen a rule that applies to this? So here I see I have a negative exponent, but I also see that I'm multiplying. Well, so let's see. There was in my other video, let's see, whenever we multiply like things, and by like things I mean whenever we multiply 2 things where the bases match, meaning that we've got exponents, which might be different, but the bases are the same, meaning the thing that gets raised to the power is the same. You add the exponents. Well, so that is applicable no matter what kind of exponent you have. So if I have x to the minus 10th power times x to the 4th power, here I'm multiplying like things. I'm multiplying things together that have matching bases. And that rule said you're supposed to add the powers together in that case. So what the power should be on these when you put them together and multiply them is whatever negative 10 plus 4 is. Okay? But that turns out to be negative 6. Now, if you wanted to transition and write that a little bit different way, we talked about what the negative exponent by itself meant, and that's 1 over x to the 6th power. Okay? All right. So there we have it with that one. And let's do 2 more just to show like what the flexibility in the rules needs to be. Okay? In algebra, you'll see that we often need to know how to rewrite something, even if we don't always do it depending on the situation. Okay? So for example, I might say that I have x to the minus 3 power here. Or I might write my final answer as 1 over x to the 3rd power. They're the same thing, okay? They don't mean anything different than each other. If it came down to calculating numbers, you'd get the same result either way. It's not like one of these is better than the other, okay? They might be different, okay? They might look different and have different numbers in them, but they're the same thing in terms of some calculation at the end of the day. So, all right, how should you write it? I'm just going to have to say that it depends on the situation and follow the instructions. All right? For the video, though, being a review, I'm just trying to get you to see that there is flexibility in how things can be written. Okay? I can write the answer to this one as x to the minus 3 power or 1 over x to the 3 power. And I'd like you to see that it's the same thing either way. Okay? Now, with that in mind, if I had 1 over y to the 4th power, suppose I needed some other way to write that, or I saw somebody write this in a different way, and I need to make sure that I understood it, then that other way would be this, okay? That 1 over y to the 4th power could also be seen as y to the minus 4 power, all right? It's just like taking this rule that I had and applying it in reverse, okay? That you could take positive exponents take the thing in the power, move it either above or below the bar, move it through the bar to the other side, and the exponent changes sign. Anytime you take something and you move it from either below or above, okay, or above to below, then the exponent will change sign from negative to positive or vice versa. So here goes with this one. It just must be that if you were to do anything with it and you moved it on top of that bar, it would become y to the minus 4th power. And this one, you could leave it alone. You've got r to the 4th power. Maybe that's fine, but depending on the situation, maybe you'd see it like this, okay? They're the same. Like I said, at the end of the day, we're going to calculate the same number. You can even try it if you want to. In math, there's usually a way to figure things out. Suppose you had your calculator and you said 2 to the minus 3 power. Is that the same as 1 over 2 to the 3rd power? Okay. You try it out with your calculator and see what you get. See if you get the same thing. I mean, I'm claiming that you will. I'm claiming that these are the same number at the end of the day, and it doesn't really matter how you write it. So you could try it. I could try it with my calculator, and you should know that you could do this too. And if you ever get lost or confused, then you've got your calculator perhaps to help you out. All right, so I got 2 to the minus 3 power. I want to tell you exactly what I get when I do this on my calculator. I get 0.125, okay? And I did say, like, with the rules applied, however you write things, at the end of the day, you're going to get the same number. On this other one right here, I'm going to do 1 divided by 2 to the 3rd power and tell you what I get. See if I get the same thing. I get the exact same thing, 0.125, okay? All right, so that's all I'm saying is going to happen. That we got these rules. They allow us flexibility to write things different ways when we're dealing with algebra or variables or whatever it is. But at the end of the day, we're going to calculate the same result. Okay? All right, so I've given you the basic concept of a negative exponent. I've given you some rules that allow you to write things different ways depending on the need. From there, I just have to say, follow the instructions, do whatever the instructions say for your answer.